Welcome to Data Project Hub. In this video, we will solve a complex SQL interview question. The question is, calculate each user's average session time. A session is defined as the time difference between a page load and page exit. This question is applicable to whatever social media apps we are using, web pages, everything. For simplicity, assume a user has only one session per day. And if there are multiple of the same events on that day, consider only the latest page load and earliest page exit. This is an important condition that we have to consider in this question. That is, consider only the latest page load and earliest page exit with an obvious restriction that load time event should happen before exit time event. So that is the condition. And output the user ID and their average session time. So we have to write a query to get the average session time per user when they are using a particular app or web page. For that, I have already created a table called as users underscore web underscore log. Let us query the table and see what is the schema, and then let us start writing query for the same. Let me execute the query, and we have a table with three columns. The first column is user ID, second column is timestamp, and third column is action. This timestamp is with respect to action. So whenever a action is taking place with respect to that action, a timestamp will be created within the table. Now we have to write a query to get the average session time per user. Let us start writing query for the same. For that, in the question it's given that we need to get the latest page load and earliest page exit. So now we can split the question into two parts, where in the first part we can find the latest page load per user per day, and in the second part we can find the earliest page exit per user per day. For that, the first part we will take the latest page load. Let me copy this. The first part is latest page load per user per day we can find in this query. That is select. We need the first column, that is user underscore ID. We need the second column, that is timestamp. But we have to make a small modification to the timestamp column. That is, we have to get the day from the timestamp column. Place this inside a parenthesis. Use the day function, which will provide us the day from the timestamp column and giving a name as day. Now we want the latest page load per user per day. For that, we can write the max function. Inside parenthesis, we can write the timestamp column, that is timestamp, which is the latest page load. Now this is taken from the table users underscore web underscore log, and we have to write a group by function based on the user ID column and the day timestamp column, day of timestamp column. Now execute this and see what is the result we are getting. Now we have a result where we have the latest page load per user per day. Now similarly, we want to find the earliest page exit per user per day. For that, let us write a second query. Copy the same query. Sorry, I made a mistake here. Latest page load. So after the from clause, we have to write a where condition also, where action equal to page underscore load. Now this will give us the latest page load time. Execute this and we have the result. Now copy this query and paste it here. Now we will find the earliest page exit per user per day. For that, replace this page load with page exit because the action name is page exit. And now instead of max, use here minimum of timestamp, that is the earliest page exit. Now execute this and we will get the earliest page exit per user per day. Execute this. Now we have the result for the same. Now what we can do is we can join the two separate tables we have created. Let us consider this table as the first CTE, which is called as page load, page underscore load. Place this inside a parenthesis, and the second query which we wrote as the second CTE, we can name the ctes page exit, open and close parenthesis, which will place this query inside the second cte, that is page exit. Now we will write a select star from page underscore load. First we will write a full join, that is full join. We will give an alias name for the page load cte, that is pl. Full join page exit page underscore exit. We will give an alias name as pe on pl dot user underscore id equal pe dot user underscore id, because user underscore id and day column are common for both the cte, that is page exit and page load cte. We have the common column user id and day, and we will write the second column also here, that is pl dot day equal p dot day. Now execute this and we will get a table. uh, I made some mistake. Let us see what is the mistake that I made. Let me go back to the query and let us start from the beginning with page load. We have to write an as over here. Now coming down, I made the same mistake for the second city as well. We will write an as close here. Now let us execute and see if it is resolved. Yeah, execute, and we can see that that is resolved. Now when we go through the result, we can see that for user id 2, we only have the latest page load time, we don't have the earliest page exit time, so we can actually neglect that record. So for that, instead of full join, we will use an inner join, which will only take the common records present in both the table. That is only because the user id 2 and day is not present in the second table, that is page exit table, we are not getting any result in this particular columns which are coming from the page exit cte. So when we do an inner join here, those record will be neglected in the final output. Now execute this and we won't be getting those records in the table. Now we have to find the difference between latest page load and earliest page exit. For that, we will modify the query such that we need only pl.userid, comma, pl.day. It is because both the table, that is page load CTE and page exit CTE, are giving us columns user ID and day. But we require only user ID and day in our final output from only one CTE. So we will take only the column from pl dot user ID, which is the page load. And in our final output, we don't require actually this pl dot day, but moving forward, we will remove that. Now we need to find the difference between the latest page load and earliest page exit. For that, we will use the function called as dateDiff, and we want the difference in seconds. The first parameter is seconds, that is the time frame. It can be either day, month, hour, minute, seconds, any, depending upon our requirement. Here we require the same in seconds. And the first column is latest page load, and the second column is earliest page exit. Now as duration, that is the time that particular person spent on that web page or that social media app. Now execute and see what is the result we are getting. Now we have a new column which is created, that is duration. When we interpret this result, we can say that the user id 0 on day 25th is spending 82 seconds on that particular app. And when coming to second row, that is user id 0 and day 28, he is spending 3685 seconds on that particular app. Now we need to find the average time spent by different users. For that, we will place this dateDiff function inside an average clause, sorry, an average function, open and close parenthesis. And also, before doing that, let me convert this dateDiff result into a decimal so that we will finally get the result in our required decimal format, or else we will convert it later so we can see what is the difference it makes. Here I will remove the pl.day because in our final output we don't require that. Also, we need to group the result based on pl.userid. For that, we will write a group by clause, that is group by pl.user underscore id. Now execute and see what is the result we are getting. Now we have a user ID column and duration, that is the average duration. But the actual output should have been in decimal format. For that, we can actually go and convert this result into a decimal output. For that, we will come to this dative function, use the cast function, cast the entire function as decimal, open and close parenthesis. Now 10 is the precision and 2 is the scale. Now put one more parenthesis, and now we have completed the query. Let us run this and see what is the result we are getting. Now we have our final result in the required format. When we initially run the query, we can see that the earlier result was 1883 without this decimal part. Because this 0.5 was neglected, hence this result was considered as an integer. Now when we converted the result of dative function into a decimal, we have the final result in the decimal format only. We can use a cast function once again, that is cast as decimal. Once again, decimal 10 comma 2, execute this, and now we have the result in the required format, which is for user 0 or user ID 0, the average duration he spent on that particular app or the web page is 1883.50 seconds. And for user ID 1, he is spending 35 seconds on that particular app per day. So this is our required output. Hope you like this video. Thanks for watching and subscribe for more. Thank you.